In today's lesson, we are going to be looking at the ambiguous case of sine. So ambiguous just basically means we're unsure of what it is. So when we're talking about an ambiguous case for sine, we're talking about a scenario where we could have multiple or two possible solutions. So just a little bit of a review. We have our sine law, right? A over sine A equals B over sine B equals C over sine C. So it's basically just comparing a ratio of a side and its opposite angle and saying that those ratios of the side and the angle are equal to the ratio of another side and its angle. So just to remember, little letters or lowercase letters represent the sides. Uppercase letters represent the angles. Right, and again, this is used when we have two sides and an opposite angle, or if we have two angles and one side. And the ambiguous case focuses specifically on this scenario, when we have two sides and an opposite angle. In that case, or when we have those cases, that's when we have the ambiguous case. So when to consider, right? So we must always consider the ambiguous case of sine when you have an oblique triangle with two sides and an opposite angle given. So for example, the length of side A and the length of side B are given. The measure of angle A is given. Angle B could be acute or an obtuse angle. And we have to consider both situations. So this angle down here, which is angle B, that could be acute or it could be obtuse depending on the scenario, right? So depending on the scenario, it could be either of these two cases. We don't know. There's not enough information given in the scenario for us to determine that. So we would have to consider both situations. And now the reason that this scenario comes up is because of the cast rule. And with the cast rule, we should know, or we should remember, that it's possible for angles in quadrant 1 and 2 to have equivalent positive sine ratios, right? The cast rule, if we go through and state, we have C, A, S, T. I'll do it in the other one as well, C, A, S, T. Right? So in these cases, we could have an angle in the first quadrant that has a positive sine ratio, and we could have a complementary or a reciprocal angle in, or say more of a complementary angle or a similar angle in quadrant 2 that would have the same ratio, because in quadrant 2, sine is positive. Right? So therefore, we have to consider both scenarios. And how do we solve for the ambiguous case? Well, the angle across from the extra side can be either acute or obtuse, so we've already mentioned that. And we're basically going to, for case 1, we're just going to use the sine law as usual. So for whatever our first case is, we're just going to use the sine law as normal to find for that missing angle. And then for the other case, or the second case, we're going to do 180 minus the answer we got from case 1. So essentially, we're going to solve for what our calculator will probably give us as an acute angle first, and then in case 2, we're going to treat that acute angle from case 1 as our reference angle. So then we do 180 minus the reference angle to get the other scenario. So let's go through an example. So example 1, in triangle ABC, side A is equal to 12, side B is equal to 17, and angle A is equal to 21. We want to find the measure of angle B. Right? And there are going to be two scenarios. So I'm going to draw my triangle out. I'm going to draw the first one. Because our calculator usually gives us the acute angle anyways, we're going to assume that's what the first scenario is. So it doesn't really matter how we label it, but it does help if we're given the two sides and we look for this angle B. Right, so side A is 12, side B is 17. We know angle A is 21 degrees. And then we're going to look for this angle. Right, so it does help if we label it so that the angle or one of the angles on the bottom is what we're looking for. So that's the first scenario, right? So this is case 1. So let's go through case 1 first. And we're going to solve for that angle B. Right, so we're going to use our sine law. So little b over sine of big B equals little a over sine of big A. Right, remember, just opposite sides are those reference sides, or those what we label the sides. So across from angle B is little b, across from angle A is little a. Plug in my information. So 17 divided by sine B is equal to 12 divided by sine 21. Cross multiply and rearrange. We end up with sine B is equal to 17 sine 21 divided by 12. And then do the inverse of sine of this answer. So 17 times sine 21 divided by 12. Take the inverse sine of that, and I get the angle B is equal to 30.5 degrees. 30.5 degrees is the first case, or the acute angle. The second one, or case 2, I'm going to draw that out of what it could possibly look like. So it could possibly look something like this. A, B, C. This would be our obtuse angle, but it would be still angle B. We know the other side is 12 and 17 and 21 degrees. I don't have to go through and do the same calculations again, because we would get the same answer, right? Your calculator usually gives you the acute angle. So we do know, though, that if we imagine it making a line across to 180, similar to what the cast rule might be, this reference angle in here would be 30.5 degrees. So for case 2, angle B could equal 180 minus 30.5. Angle B could equal 149.5. So those are the two possible scenarios for angle B. Now, we don't know which one it is because we don't have enough information. If we knew what this upper angle up here was, then yes, maybe we would be able to determine which scenario it is. Or if we knew the other side length down here on the bottom, if we knew that side length, that would help us as well, because that would tell us which scenario it is. Right? So we don't know for sure, so we have to assume it could be either of these two cases. Example 2, similar idea. I don't think exact same values. Right, so let me go through and change this up just to match, or just to match the notes. So A is going to be 8. It's going to be triangle ABC. B is going to be, we're actually going to be looking for side C. And side C is going to be 10 centimeters, and we are going to be given angle A again, which is 34 degrees. And we want to find the measure of not angle B this time, but angle C. So slightly different information, right? But let's go through and draw our triangles. Right, so the first case, we're going to say this is A. We know angle A is 34 degrees. We know side A is 8. Right, I'm given side C, so I'm going to label this side C, so I can place C here. We'll call this B up here. Right, so again, you want to try to label in a favorable way so that it kind of helps you out as you go through and solve, so that it's kind of similar throughout the different, similar process throughout these different steps. So I want to find angle C. So again, I'm going to look at two different cases. Case 1, right? So because I have two sides and an opposite angle, right? Two sides and the angle opposite of one of those sides, I'm going to assume that I have the ambiguous case. So go through, I'm going to look for angle C. So I have A over sine A equals C over sine C. I'm going to plug in my values. So side A is 8 divided by sine of 34 is equal to 10 over sine C. I'm going to solve now the sine law for angle C. So I'm going to cross multiply and then move over or rearrange. So I'm going to end up with sine C is equal to 10 times sine 34 divided by 8. Do the inverse of sine to get angle C. Sine -1 of 10 times sine 34 divided by 8. And we get C is equal to 44.3 degrees. So that's our one scenario. That's the acute angle that angle C could be. We do have a second option, which is this acute option, or sorry, this obtuse option. Looks too much like a 90-degree angle. Right, so again, just it's all labeled the same, but I can't go through and recalculate it because I would get the same thing. My calculator would give me the same answer. Right, so again, I could assume that it's an obtuse angle, so the angle that I just found, that 44.3 degrees, is my reference angle. So for case 2, we could do that angle C is equal to 180 minus 44.3. Get angle C is equal to 135.7 degrees. So those are my two possible angles for angle C. Again, I don't have enough information to determine which one is which. Maybe again, depending on the scenario, if there was a scenario that might help, or if I was able, or if I was given additional information. So the last question: a lighthouse at point L is 10 kilometers from a yacht at point Y and 8 kilometers from a sailboat at point B. From the lighthouse to the yacht to the sailboat is an angle of 48 degrees. Right, so first, is it necessary to consider the ambiguous case? In this case, yes, it is. Yes, because we have two sides plus an opposite angle. So next we want to sketch the two possible diagrams. Right, so first, let's just draw our acute angle. We have our lighthouse L, we have S, and we have Y. Right, and again, I'm just labeling this based off of what can help me the most, right? Keeping it similar to all the other diagrams, so where we're looking for side S. So in this case, the two possible scenarios, right, aside from this diagram, we know that from the lighthouse to the yacht to the sailboat, or angle LYS, is 48 degrees. We know that the lighthouse is 10 kilometers from the yacht, so this would be 10, and this would be 8. The other scenario is where it's an obtuse angle. So still 48 degrees, still 10, still 8, SYL, but however, in this case, the sailboat is closer to the yacht. And again, we don't know which scenario is which. We don't have enough information. But let's look for how far away the sailboat is from the yacht. And again, we said there are two possible answers. Right? So what we're going to do first is we're going to find angle S. That's the first thing we're going to do. So I'm going to use my sine law. So I have a full pair and half a pair. So sine of y over sine, not sine of y. So little y over sine big Y is equal to S over sine S, capital S. So we have 8 over sine 48 is equal to 10 over sine Y, or capital Y. Similar steps to the exact or to the same as the previous examples. Right, first, we're going to cross multiply and rearrange for sine Y. So sine Y is going to equal 10 times sine 48 divided by 8. Rearrange, rearrange and do the inverse of sine. We get Y is equal to, or sorry, not Y, S. I don't know why I called it Y. Sine S. So we get S is equal to 68.3 degrees, roughly. So now I know this angle here is 68.3 degrees, or it could possibly be that. The next step, before I can find this unknown side, right, X, or say just L, before I can find that side, my next step, so step 2, I'm going to find angle L. So I'm going to find angle L. Right, this one's easy because I already know the two angles in a triangle. So 180 minus 68.3 minus 48 is going to equal 63.7 degrees. So I'm going to fill that out in my triangle, 63.7 degrees. And then my final step now is I'm going to find side L. So I can use my sine law. So side L over sine L is equal to, I can pick any other side. I'm going to use the one that was given to me, or not any other side, any other pair, but I'm going to use the one that was given to me, which was Y over sine Y. L, I don't know, divided by sine of 63.7, which we had just found, is equal to 8 over sine 48. Cross multiply and rearrange for L. We'll get L is equal to 8 times sine 63.7 divided by sine 48. And L is equal to 9.65 kilometers. So that's one scenario. That's case 1. Case 2 is very similar. However, in step 1, for find angle S, I'm going to just use the case 2. So I'm going to do 180 minus 68.3. We get S is equal to 111.7 degrees. So again, those are our two scenarios for that angle. Now, step 2 and step 3 are very similar to what we just did, except with a different angle. So if I know that this is 111.7, I can find angle L by just doing 180 minus 111.7 minus 48, and we get 20.3 degrees. So angle L is, this scenario is 20.3 degrees. I can now use the sine law, similar to what we just did in the last one, to find side L. So sine law, again, I'm going to use this side that's given to me, and I'm looking for L. So L over sine L is equal to Y over sine Y over sine Y. L we don't know. Sine of angle L is sine of 20.3. That angle we just found in the previous step. Y is 8. And sine of angle Y is sine 48. I'm going to cross multiply and rearrange for L. So I'll get L is equal to 8 sine 20.3 divided by sine 48. So again, very similar to what we just did. We get L is equal to 3.7 kilometers. So those are the two possible scenarios. So therefore, the boats could be 3.7 kilometers or 65 kilometers apart. Again, based off the information we have, we don't know which is which, so we just want to be mindful of that. It could be either or. So again, this was just kind of looking at specific scenarios with our sine law formula or the triangles using sine law formula. Again, depending on what information we're given, we might have the ambiguous case, which means we have two possible angle measures, which would then in turn give us different side measurements as well. Right, so again, just going back and taking a look at the general, the two possibilities, right, an acute triangle or an obtuse triangle. So depending on the situation, you do have to be mindful and think of the two different scenarios, or just understand that there are could be two possible answers.